Hi, my name is Professor Matthew Harrison. I work at the University of Tasmania in Australia. Today I'm going to briefly introduce the principles behind carbon and biodiversity markets associated with planting trees on farm. I'll refer mainly to the Australian government scheme, although there are many comparable schemes around the world that work on the same principle. And that is you establish a baseline, which is the status quo or the current condition, and that can be a bare paddock or a bare field, or it could be existing plantation forestry. And then you have to demonstrate additionality, so you demonstrate how you've actually changed your measurement, changed your current practice, and then you actually receive income for that. There are a bunch of rules depending on the scheme that you enrol in. In Australia we have what's called the ACCU scheme, or the Australian Carbon Credit Unit scheme, uh, and underneath that there is a whole bunch of carbon instruments or methods as they're called locally. They're actually carbon policies or carbon markets. Um, for each additional tonne of carbon that you've demonstrably sequestered by the project, so you've changed your practices, you've shown that additional carbon is sequestered to what would have been sequestered had you not enrolled in the carbon market, you get paid a market price. Like any market, carbon prices are up and down. In Australia, the current spot price is about $38 per tonne of CO2, but they've gone up and down over time and will go up and down in future. The crediting period, it's a long-term game. So the minimum period is 25 years, and the maximum period for the Australian government scheme is 100 years. So it's a long-term game. Uh, ACCUs for the short carbon projects of 25 years receive a discount in case you've lost carbon. That can be due to a drought, for example, or even a bushfire where some trees burn down and you've lost some of the carbon that you've sequestered. So there's various discounts. So one of them's a permanence buffer, the other one's a risk of reversal. So there's a 25% discount for every tonne of carbon you sequester in a 25-year project. Or if you've enrolled in a 100-year project, you receive a 5% discount. Measurement or modelling is typically done on a 5-year interval, but it can be done sooner depending on the method. And depending on the method, it can be carbon sequestration on these 5-year intervals is either measured or modelled. And if it's modelled, it has to be done with the certified Australian government model, which is called FullCam. As I said at the start, projects need to demonstrate that the carbon sequestered is additional. That doesn't necessarily mean that you've just planted trees anew. It could be that you've already got plantation forestry and you change your rotation. So instead of harvesting maybe every 20 years, you change that rotation to a 30-year cycle. And in certain cases, you can be eligible to show that you've got additional carbon sequestered and therefore you're paid for that additional carbon. Because the government's main aim is to remove additional carbon dioxide out of the atmosphere and to pay landholders for that, not for the carbon that they would have sequestered anyway. So ACCU prices, like any market, have gone up and down over time. So you can see they spiked there in late 2021 and then they fell down after that. These are Australian prices, by the way, so they're between $30 and $40 a tonne. If you compare them with large-scale generation certificates, that is the price for solar energy, for example, that has actually been falling since about September 2022, perhaps due to oversupply. A lot of people got solar on their roofs and therefore there's greater supply. And like all markets, the price is dictated by supply and demand. So what actual methods do we have in the ACCU scheme in Australia for paying landholders for sequestering carbon in trees? A popular one is plantation forestry. Now you can establish a new plantation specifically for the ACCU scheme there, or you can convert an existing plantation from short to long rotation. You have to estimate carbon sequestered using the model called FullCam. And like any carbon market, there's a bunch of eligibility rules. And so one of those rules is the land that you're doing it on can't have been a native forest in the last 7 years. There is reforestation and afforestation. Reforestation meaning you put a forest back where there was once a forest. Afforestation meaning you establish a forest where there wasn't one. That can be either blocks or belts, and the carbon sequestered is actually taken from physical samples. And the most popular one in Australia is this establishment of native tree species. So that's called environmental or mallee plantings. Your project area needs to be more than 0.2 hectares, and the carbon sequestration is estimated using the model called FullCam. If we just look at the actual projects registered in Australia over time, this is freely available on the Clean Energy Regulator website. In 2019, not really many projects registered, and since then we've seen a steady increase, mostly in vegetation-based projects in these green bars here, to a lesser extent soil carbon, particularly since 2020, which are these yellow bars here, and then there's a smattering of other projects as well, so waste and savanna fire management and transport and so on. If you look at the actual carbon credits that have been awarded, so they've actually been awarded to projects, the greatest has been tree carbon, so carbon in vegetation, so these green bars, and the actual legend has changed here since the last slide, so these yellow bars are now waste, not soil carbon. So the most carbon credits have been awarded for vegetation tree-based projects, to a lesser extent waste. If you actually focus on the actual tree-based methods, the most carbon credits have been awarded for environmental plantings, about 2.9 million over 264 projects. To a lesser extent plantation forestry, very, very few projects in the reforestation, afforestation method. So what do you actually do with the carbon credits when they've been awarded? There's many different things you can do, and that's a very important consideration. You can sell them to the Australian government. You can sell them on the secondary market, provided those parties hold a contract. You can retain them. This is the same as any carbon market, and they can be used to counterbalance your other farms' emissions. That's actually called insetting, so a lot of banks and retailers are doing that now. Insetting is preferable if you're wanting to market a low emissions or a carbon neutral product. It's important to note that you can't sell your carbon credits and claim them as part of your farm's business as well. Because if you were to do that and you had sold them, it's probable that someone else would be also counting them towards their business. So for example, if you sold them to an airline who wanted to offset their own emissions, that airline would then say, okay, yep, I've bought 100 accus and I'm offsetting my business's emissions with those 100 accus, so you can't use those 100 accus to say that you've reduced your emissions as well, because that's double counting. If they're sold overseas, well then the nation with which they're sold to will probably count them as part of their offsets, because they've purchased carbon offsets from us, so we can't count them as part of our national inventory then, or even the forestry or the agricultural sector. So it has implications on accounting, and particularly industry targets where the carbon credits are sold. The nature repair market was one of the world's first biodiversity markets. It was Australian government legislated that in late 2024. There's a bunch of different things that you can do there. The main aim is environmental stewardship, so paying people for restoration of biodiversity outcomes through planting trees, establishing vegetation along waterways, protecting existing habitat, encouraging use of biodiversity indigenous knowledge. Similar to the carbon market, they can be 25 or 100 years or other approved length. You get one biodiversity certificate per project, so that's a bit different to the carbon markets. You can sell the biodiversity certificate, you can hold on to them, or you can deposit it with the Clean Energy Regulator. It's important to note that the nature repair market facilitates stacking of a carbon project with the biodiversity certificate. So it's plausible that for some projects, for example planting a native species where you can demonstrate biodiversity benefits, you could possibly get a biodiversity certificate and accus, and so therefore that increases the financial attractiveness of a project, because you can stack together practices on the one area which in Australia you haven't traditionally been able to do under the Australian government scheme. The price of biodiversity really depends on where you are, so it's very context dependent. So the way I liken it is a little bit similar. Biodiversity is like the price of opal, whereas carbon is like the price of gold. The price of gold is paid per unit mass. It might be $3,000 or $4,000 an ounce. Same with carbon. The more mass you have, the more you get paid. Pretty easy. Biodiversity, more like opal. So if you have a blue opal, for example, there's apparently lots of that, and because there's lots, the demand for it is low. So therefore, the price of it's pretty low. It's only $1 or $2 a gram. If you think about red opal on a black background, that's apparently very, very rare, and it's highly sought after, and that can sell for $48,000 to $50,000 a gram. That's because there's not much of it, and everyone wants it. It's very similar with biodiversity, from what I can tell. It depends on where you are, what you're protecting. Is it a threatened species? Is it an endangered species? And who wants your biodiversity certificate? So it's very much contextualised to your environment. That brings me to what I call the sequestration versus mitigation conundrum. If you were to plant trees in some year, the carbon sequestration is a non-linear curve. So it goes up to an inflection point, and after that point the carbon removals or the rate of sequestration diminishes. And that's because trees approach maturity and they're not sucking as much carbon out of the atmosphere. In contrast, if you think about carbon dioxide and methane from your livestock and or nitrous oxide from fertiliser, assuming everything else remains the same, they just keep on continuing upwards. That means it's just a constant emission. So if you're relying on this red line, like planting trees or soil carbon, to offset your other farm's emissions, which is this blue line, which a lot of people do, you can see that it's going to become increasingly difficult over time because the trees will approach maturity. The rate of carbon sequestration diminishes over time. So that makes it increasingly difficult to use carbon sequestered in trees to market a low emissions or a carbon neutral product. So how to get around that? The other thing that I would like to point out before I talk about potential alternatives is that if you reduce, say, enteric methane through an anti-methanogenic livestock supplement, once that methane is avoided, it's permanently avoided. It can't be re-released into the atmosphere. Similar nitrous oxide, if you've changed your nitrogen rate or type of nitrogen or placement in the soil to deliberately avoid nitrous oxide and it's certified, well, once that's avoided, that's cumulative, and so it cannot be re-released into the atmosphere. In contrast, if you've got a big forest and then you get a fire, you've lost all that carbon. So the carbon sequestered over the last 30 years has been lost. So it's plausible that we should be valuing reduction of nitrous oxide or avoidance of enteric methane in a different way to what we do for carbon sequestered in trees. That said, there are a whole bunch of nature-based benefits associated with planting trees, much wider than carbon. So if you think about biodiversity habitat benefit associated with planting native species, you don't really get a lot until 15 or 20 years after the tree is planted. In fact, the shape of the biodiversity benefit curve is pretty much the opposite to what it is for carbon sequestration. So if you're planting trees, it really depends on what your aspiration is. Is it for productivity benefits? Is it nature-based solutions? Is it carbon sequestration? Or is it something else? If it's for carbon, and I got this slide from Rod Keenan at the University of Melbourne, you want to think about, well, how much do you plant? And can you have something like asynchronous plantings? If you plant 20 hectares in year one, you get a whole bunch of carbon sequestration in the first 10 years. And then as your trees mature, your rates of carbon sequestration fall. That's a problem because your emissions, the CO2 and methane and everything, are probably just the same. And even if you're sequestering much more than your farm's emissions, it doesn't matter because after 20 years your rate of carbon sequestration will have fallen. In contrast, if you only plant 1 hectare per year for 20 years, you get this grey curve where your carbon sequestration just increases and increases and increases for 25 years, which is actually the duration, minimum duration of a carbon project in Australia. So, you know, that might be more preferable if your aim is to use carbon sequestration to offset a farm's emissions. It's important to note that planting trees has a whole bunch of other co-benefits and trade-offs, and I think these are probably even more important than carbon per se. For example, a lot of farmers have livestock and or cropping, and so trees can provide critical shade and shelter by far above that of a bare paddock alone. So, for example, some farmers in Australia have actually shown that land mortality can be reduced by up to 36%, which is a substantial productivity co-benefit. You've got more animals to sell, and so that's an economic benefit in a big way. If you're replacing pasture land, you need a value. So, for example, trees replacing 3 dry sheep equivalents per hectare, or 3 sheep per hectare, need a carbon value of about $106 a tonne. Even if you're planting trees on an area that has no grazing, that needs about $96 a tonne. So it's not free to plant trees, and there is a cost associated with doing it. But often non-monetised, there's a whole bunch of wider ecological and environmental benefits: pollination, pest control, aesthetics, fire risk, and so on. So it's important to consider these. I detail these with some colleagues in a paper called Carbon Myopia that's freely available online. If anyone wants a copy, I'm happy to send it as well. That's all I'm going to say for today. Thank you very much for tuning in, and hope to see you next time.